Right now, at this exact moment, a planet that has been hiding in plain sight for over a decade now, orbiting one of the most studied stars in our entire galaxy, has just been found by the James Webb Space Telescope by looking at that star system in a way no one had ever tried before. As at the time of making this video on July 15, 2026, astronomers announced the discovery of Beta Pictoris d, a gas giant lurking just 63 light-years from Earth, faintly visible in archived telescope images stretching back more than 11 years. Hundreds of scientists had pored over data from this star system. Papers had been published, dissertations had been written, and the whole time, this planet was sitting right there, waiting to be found. This star sits in the southern constellation of Pictor, the painter, and it's been a celebrity in astronomy since the 1980s. In 1984, it became the very first star to have its debris disk directly imaged. Think of a debris disk as the cosmic leftovers of planet formation, a swirling ring of dust, gas, and rock surrounding a young star. And Beta Pictoris is young. At just 23 million years old compared to our Sun's 4.5 billion, this is essentially a teenage star system. We're watching planetary formation happen in something close to real time. In 2008, astronomers scored another landmark when they directly imaged an exoplanet orbiting Beta Pictoris. That planet, Beta Pictoris b, was one of the first exoplanets ever photographed, a bruiser roughly 10 times the mass of Jupiter. Then in 2019, a second planet, Beta Pictoris c, turned up through radial velocity measurements, also about 10 Jupiter masses. Two massive gas giants circling a young star with a bright debris disk. It was already one of the most fascinating systems in the sky. And then came the surprise. In December of 2025, Ben Sutcliffe, a postdoctoral researcher at the University of Edinburgh, was using the ERIS instrument on the European Southern Observatory's Very Large Telescope in Chile. He wanted to study Beta Pictoris b to see how it had changed over time, but while working through the data, something unexpected appeared. A faint signal. A speck of light that had no business being there. Astronomers have learned the hard way not to trust random bright spots in their images. Instrumental artifacts, noise, reflections from the debris disk itself, there are 100 things that can fool you. Sutcliffe's colleague Marcus Bonza at ESO ran machine learning algorithms to scrub the image clean. The speck remained. Meanwhile, on the other side of the world, something remarkable was unfolding at exactly the same time. A team led by Aidan Gibbs and Jean-Baptiste Rufio at the University of California, San Diego, was pointing the James Webb Space Telescope at the same star system. And they found the same planet. Independently, just days apart. Two groups, two different telescopes, one on the ground and one in space, converging on the same discovery within the same week. Sutcliffe called it a serendipitous discovery. Bonds described the planet as having played hide-and-seek for 11 years. So why had Beta Pictoris d stayed hidden for so long? The answer lies in what makes it different from its siblings. This planet shines 100 times fainter than Beta Pictoris b, making it the faintest exoplanet ever imaged from the ground. At 2.4 Jupiter masses, it's dramatically lighter than its siblings, which each clock in around 10 Jupiter masses. It orbits 26 astronomical units from its star and takes a staggering 91 years to complete a single lap. And it sits embedded within one of the brightest debris disks known, a disk that acts like cosmic fog, scattering starlight and making it nearly impossible to separate a faint planet from the surrounding structure. But here's where the story gets truly revolutionary. The Webb team didn't find Beta Pictoris d by spotting a dot of light. They found it by reading its chemical fingerprint. Rufio put it plainly, there was an unexpected bright source of light, but we've learned not to trust bright blobs in images. By obtaining a spectrum at the same time as the image, we were able to quickly confirm our suspicions. That's spectroscopy. Instead of just capturing a picture, Webb split the incoming light into its component wavelengths, revealing the unique molecular signatures of the planet's atmosphere. Carbon dioxide, water, methane. These molecules absorb and emit light at very specific wavelengths, creating a fingerprint that's unmistakably planetary. The dusty debris disk doesn't produce those signatures. Instrumental noise doesn't produce them either. Only a planet does. As Ruffio explained it, a spectrum contains an incredible amount of information. You don't just learn that something is a planet, you immediately begin learning about its temperature, chemistry, and motion. And that word motion is critical, because spectroscopy doesn't just reveal composition, it reveals radial velocity, the speed at which an object is moving toward or away from us. That gave the team yet another independent confirmation that what they were seeing was a real object in orbit. This technique represents a genuine turning point in exoplanet science. For decades, direct imaging has been about finding bright points of light next to stars. Beta Pictoris D proves that spectroscopic detection can find planets that are simply too faint for traditional imaging to catch, planets that have been hiding in data we already have. And when astronomers went back through archived observations spanning more than a decade, there it was, faintly, barely, but unmistakably there. As Oxford's Jane Birkby put it, Planet D, it seems, has been playing a game of hide-and-seek with us for over a decade, and only now can we say, found you. Beta Pictoris is now only the second star system ever to have 3 or more planets directly imaged. Beth Biller of the University of Edinburgh noticed a compelling pattern in this. Planets seem to have friends. Many of the famous directly imaged exoplanet systems seem to have multiple giant planets in the same system. This 3-planet system gives scientists an extraordinary laboratory. 3 worlds born from the same disk of material, at the same time, around the same star, yet with dramatically different masses and orbits. Understanding why requires cracking the physics of planet formation itself. The James Webb Space Telescope, which launched on Christmas Day 2021 and cost $10 billion, 20 times its original budget of $500 million, keeps justifying that investment with discoveries like this one. Its 6.5-meter primary mirror and position at the L2 Lagrange point, nearly 1 million miles from Earth, give it capabilities no ground-based telescope can match. But this discovery also reminds us that ground-based telescopes remain essential. The Very Large Telescope pulled off an independent detection, and with ESO's Extremely Large Telescope expected online around 2030, and NASA's Habitable Worlds Observatory planned for around 2040, the next generation of instruments will push these spectroscopic techniques even further. The implications are staggering. If a planet can hide for over a decade in one of the most studied star systems in the sky, how many others are buried in archival data right now, waiting for someone to look at the light in just the right way? Beta Pictoris D didn't need to be found. It had been there all along. What changed wasn't the planet. It was how we learned to see.